I think it is, I didn't number them and I should have. It is. First page, second page, third page. It's the fourth page. It says review 1.5 to 1.7. All right, and I'm not doing the whole thing. I am doing a very focused review so that you know exactly what you need to know. So the first problem I'm doing is number 4. We are going to find the inverse of problem B, problem C, and problem E. All right, so we are on the page called Review 1.5 to 1.7, and we are on problem 4, finding the inverse of these 3 problems. All right, so how do we find an inverse for problem B?
Why?
Well, this is y. You might want to do this on another sheet of paper because it's really easy. So once you put your y in, then you switch your variables, right? And then get y by itself. So your inverse is right there, x plus 2 over 2. That would be the answer to the question. So again, how did we do that? We switched our variables and then got y by itself. Right? Okay, now what? How do we do C? Same thing. Switch the variables. Okay. And then what? Get this over here. Our variables, move this over to here.
Why would you not do y plus y? What would you
I'm multiplying by this.
I thought.
It's like multiplying by -5. I don't change it to a positive.
I thought you were switching it to y.
No, I'm multiplying this whole parentheses over to here. Now what do I need to do? I need to distribute. And then here's the step that sometimes we forget. We need to get all of the y's on the same side. So this is coming over here, and this is coming over here. So xy minus y equals 5x plus 1. Right? And then take a y out. And then divide. Yep. So your inverse is 5x plus 1 over x minus 1. That would be your answer. So those are the steps that we go through. More than that first one. And then the last one I want to do, how do we find the inverse of the cube root? Switch the variables, cube both sides, and you're done. What is your inverse then?
X to the third.
Yep, x to the third. So when we find an inverse, we more variables, and then get y by itself. Do whatever you have to do to get y by itself. All right, so now I want to look at question 5. So look at the inverses that I found. I have them in boxes here. Tell me the domain, or write the domain of these inverses. So on your test, you'll need to find an inverse and then tell me the domain. What do you think the domain of this guy is?
All real.
All reals. Perfect. When do we have issues?
When there's X in the
When there's an X in the bottom, or when you have a radical, right? How about this one? What's the domain of that one?
negative 1.
It can't be 1,
Yeah.
right? So if you think about it on a number line, it can be all of this and all of that. So negative infinity to 1, or 1 to infinity. Everything except 1. All right? Now, what about this one?
All real.
All reals. Your domain there is just like this one. Because what don't we have?
Square root or
A denominator or a square root, right? So we're good. We're good. All right. Skip to 7. Number 7. Someone has already done the work and wants you to prove that these two things are inverses. Now, I need you to listen carefully. The only way to officially prove this is to evaluate both compositions. There is no other way, so don't suggest another idea. They've already all been suggested and they've all been shot down. This is the only way. Okay? So if these are my two functions, I'm going to evaluate this. So what does this mean? Take G and put it into F. So 2x minus 1 plus 1 over 2. That's what I get if I take my G and plug it in. Correct? Now simplify. What happens to these two? So 2x over 2, that just equals x. That's what I want to have happen. Now I'm going to do this one, and the same thing's going to happen, hopefully. So this says, take this and put it in here. So 2x plus 1 over 2 plus 1. Right? So that's gone.
Minus 1.
Oh, yeah, thank you, minus 1. So I put this right here. So now I have x plus 1 minus 1, which is, that's my proof. So there will be a problem on the test that says show or prove or something. These two things are inverses. So what are you going to do? You're going to do both of these problems, and what is going to happen? If it's a yes, they're both going to turn out to be x. If the first one you do turns out to be x minus 2, then you're done, because they both have to be x.
You don't just find it.
No. Were you not listening to me?
I was, but
Okay, there's no other option. This is the proof. This is the proof. All right, number 8. Now, if you don't have any graph paper, because you can't possibly do this on this. If you don't have any graph paper, you can get a piece of graph paper if you want it, or do it on regular paper, I don't care. Graph paper, I'll put it right here on my bad kid does. If you need a piece, we're gonna sketch. Alright, so the picture that we are sketching has a triangle like that and a trapezoid like that.
Which question is this?
This is number 8. We're gonna do some sketching. Alright. I am picking out problems from the review sheet that I know you're gonna have to be able to do on the test. The one thing you're gonna have to be able to do is sketch. So, let's look at this first one. What does that 3 do to that picture?
Multiplies all the ones.
Multiplies the y's, or the height, by 3.
Yeah.
So what does that mean? That means that triangle that I drew, that was up 3, is now gonna be up 9. It's the same triangle. It's like you had, like it's a rubber band and you just pulled it up. So it's very tall and skinny. Now what about my trapezoid?
To go down.
Well, originally, this was 1. So times 3, now it's going to be 3. So it's the same trapezoid, but it's just stretched. Y times 3. What about the next one? This one has 2 things. What does that do?
And flips it, flips it.
Upside down,
Upside down.
and this goes left 1. Now, if you can do all that at once, great. You're also free to do it in 2 different steps. So, if I did it in 2 different steps, you can do it either however it works for you. But if I took it left 1 first, left 1 would mean that instead of being 1, 2, 3, I would be over here at 4, negative 4. And my trapezoid is down. So it would look like that. It's supposed to be down. Okay? And then my triangle would actually be centered on the y-axis.
Are you doing one at a time?
I'm doing one at a time. You can do them together if you want. I did one at a time. So this takes care of the left part. Everybody okay with that? Now I'm going to take it and flip it upside down. So my trapezoid is going to come up, and my triangle is going to come down. So the pink will be the answer to that question. All right, we okay with that? Gotta know your rules, guys. All right.
Multiply X.
Well, watch it, watch it, watch it.
Okay.
This actually divides the width.
Yeah.
You got
So the width is the x's. We're dividing the x's, right? So what does that mean? Go back to the original picture. How wide is the original original triangle.
2 y.
Now he is only going to be 1 y. We're squishing it. That number divides the width. This number multiplies the height. Now, where am I trapezoid? How wide is he?
4, 3, 4.
1, 2, 3. So he's now gonna be 1.5. So there's my squishy little trapezoid. Still down 1 like the original, but now only 1.5 wide.
It's like I could just like play with it. Alright. Okay.
All right, this one's got 2 things happening also. What are the 2 things?
You do up 1.
Up 1,
And up to the right, sideways.
so sideways flip, yep, so this one's flipping sideways. So what that means is, anything on the left is now gonna be on the right, and vice versa. So I think I'll do that first. So back to my original picture, the triangle's gonna be over here. I'm doing this part. The trapezoid's gonna be over here. And there, that was my original. This is my sideways flip. Would you agree with that?
Yeah.
Now, we're gonna take the whole shebang
Up Y split.
and lift it up 1. You do not need to draw that line in there. I do it because that shows me kind of where my point's gonna be sitting now. That's like the floor of my problem. You don't need that dashed line. I do that for me. You don't need to do it, but you do need to have that pink picture. And the last one, what's going on here?
Take everything from left side and leave it.
No, not this one. This one's bottoms up. So this one takes everything from the bottom and brings it up.
Everything's positive.
Make it all positive, make it all above the x-axis. So trapezoid is gonna be the trapezoid, but it's gonna come up. The triangle is already up, so nothing's happening to him. All right? Now, it's not on that particular exercise. It's in more of the review. So again, you can do as much of that review as you want. But real quick, if we had this, what's that? That's different than this.
Here.
This, we draw the right side, and then we draw it on the left. So that would be absolute value of x. What, Vernon?
There's a negative in front of the F, does that mean you copy the left side instead of the right?
You mean if I had a negative here?
Yeah.
Yeah, I would draw that picture and then reflect it across it and change it.
So it's always draw the right side.
Always draw the right side. All right, number 9, need a calculator for number 9. We're gonna maximize the volume of the box. And the paper is 12 by 18. So, who remembers
2x.
how to find my equation? I need to have an equation to put into my calculator. Who remembers what it is?
Is it 18 minus 2x times 12 minus 2x times x?
It is.
Wow. Thank you.
It is always the same equation. You just put in however big your paper is right here. That's your equation. Probably also gonna ask you for the
0 to 6.
0 to 6, beautiful, and how did we know that?
It's half of the smallest
Always
one.
0 and then half the smaller one, good. So we set our window for this guy, that's your X min and max. Type in your new equation. And hit graph. Oh, well, this happens sometimes. I don't know what yours looks like, but mine looks like this. That happens, no big deal. What does that mean?
Put your Y
I gotta
down.
go back to window and make my Y max higher.
It's 400.
400 that I put in, yep, and that looks good. So I put in 400. You could put in 350 probably, and it would be okay. You just want to see the top of the hill, and then you're going to second calc max, left bound, right bound. And you are not done until your calculator literally says maximum. You have to see the word maximum on the calculator.
Top left?
Mine's on the bottom, but yours could be on the top. When you see it, you know you've got it, and it's 2.354, comma, 228.162. Is that what you got, Joe?
Yeah. Yeah.
Every time you maximum on your calculator, every time, you are going to get a point, an X and a Y. The question says, maximize the volume. So the maximum volume is 228.162 cubic inches. What question would that number answer? How big are the corners? So you gotta be careful. You're always gonna have two numbers, you gotta pick the right one that answers whatever question is asked.
So the Y, the volume, the X, and the points.
Yep. All right, number 13. Find the transformations that would be necessary to move this to here. This is number 13. Now, guys, both of these are parabolas. Would you agree with that?
Yeah.
They're both opening up. I want to pick this one up and move it so it's there. And I want to know how do I do that? How many steps do I have to take? Well, where is this one sitting? Left 2, down 8. So this one is down here at -2, -8. Would you agree with me?
Yeah.
Where is that one sitting?
Right.
Right 3, down 4. So this is an easy question. I gotta get from here to here. So what am I gonna have to do? I'm gonna have to go right 5 and up 4.
You got that today?
Yep, the order doesn't matter. So describe the transformations that would be necessary. What changes? You're gonna have to go right 5 and up 4. Now, what if we put a negative out in front of that one? We're still gonna go right 5 and up 4, but we're also gonna have to flip it upside down, right? So we're describing the changes. All right, turn it over, back side, same page on the back side. And look at number 4. called parametric equations. And your job is to find an equation in x and y that represents this set of points. Now, what's up here on the board, you guys? X's, Y's, and T's. I only want X's and Y's. So how could I get rid of the T? So I could up here say x minus 1 equals T. And then this could be plugged in here. So y equals x minus 1 squared. Is that an equation in just x and y? Yeah, that's it. That's your answer. So in this problem, what is your goal? Get rid of t. However you do that, Elijah substituted. He said, I'm going to solve for t and substitute it in perfect. Number 5, vocabulary question. Is this function 1-to-1? Yes. It passes the vertical line test and it passes the horizontal. If you are 1-to-1, you pass the vertical line test, no repeating x's, and you pass the horizontal line test, no repeating y's? Yes, 1-to-1. Now, what if I drew a parabola? Not 1-to-1 because it does not pass the horizontal line test. All right, number 8. This is really simple, but I don't remember talking about it specifically. We talked about it in general. N and n inverse are my two functions. They're inverses of each other. If you put 5 into n, you get 11. What happens if you put that 11 into the inverse? You should get 5. Exactly. Exactly. So if f of 3 is 10, then f inverse of 10 is going to have to be 3. Because what happens, guys, with inverses? Don't your x and your y switch? Yeah, easy question. All right, number 12. On my daily 5-mile walk, I try to jog 1.5 miles. What percent of my journey is spent walking? Okay? I don't overthink this. How much did I walk? No. How much did I walk? The whole journey is 5 miles. I jogged 1.5 of that, so I walked 3.5 of it. Right? The whole thing was 5. I walked 3.5 of it. So what is 3.5 divided by 10?
70%.
Or by 10, by 5. 3.5 divided by 5. 70%? 0.7? So what percent of my trip did I walk? 70% of it. Right? Easy. Okay. Number 9E. 9E. This, we just did a bunch of graphing. This is backwards of that. Look at 9E. I have the picture, the originals at the top. I've drawn a new picture. What has changed in the new picture? It's flipped upside down.
Down, or upwards. Originally it was it divided by 2.
Divide by 2 and flip around.
Yeah.
So negative y equals negative f
Okay,
of 2
so
minus 1.
would everybody agree that E is upside down of the original?
Yeah.
Now notice the original triangle going down is going down 2. That triangle is now going up 1. So I didn't move it, I shrank it,
2x.
right? Shrink it. Now, I shrunk it vertically, the y's. So how do I write that in the equation? It's gonna be a negative
Parentheses,
2.
1/2 f of x. Because what does that number do?
It divides the
It,
y.
well, it multiplies the
y.
height, right? And didn't I cut it in half? Isn't my height half of what it was? This turned it upside down, this made it half as big.
Wait, what happens when you do the 2x? Oh,
That's
minus
width.
x.
That's width. And look, is anything, look, aren't they all the same width as they were originally?
I don't like extra y.
Yeah, what was y?
It only changes the lines.
So that one just changed.
Flipped it over and made it half as tall. It flipped it over and made it half as tall.
So if the number's right next to that affects the y.
Yes,
And this is how it does.
yes, yes. All right. The height of a cylinder is twice the diameter. I'm making it up.
Oh.
Write the volume as a function of the radius. Okay. So we're not doing an equation, we're just gonna write, we're gonna write an equation, we're not solving it, we're just gonna write it. Okay, so here we go. What is the volume of a cylinder? We talked about this the other day. You guys knew this. The volume of a cylinder is pi r squared h. And that formula right there is perfect. It's wonderful. But volume is in terms of radius and height. And we want it only to be in terms of radius. So go back up into the problem. What did they tell us? The height is twice the diameter. Right? Well, I don't want D's either. What do I know about diameter?
That's
Twice the radius. So I can say 2 times 2r, which is 4r. So the height is 4r's. So I'll take that out and substitute in 4r's. So now what's my volume equation?
Pi r squared is
4 pi r cubed. And you're not doing anything with that, you are simply writing it. Alright, so let's do one more of those. Yeah. Let's say that let's say the diameter of a cylinder is 1/3 the height. And we want to find the volume in terms of the radius. Okay, so we still got a cylinder. I don't know what that is, it's cylinder. The diameter of a cylinder is 1/3 the height. Find the volume in terms of the radius. Okay, so what's the volume? Pi r squared, which would be fine, except I only want r's. Right? So when I come back up here, diameter is 1/3 the height, which means 3 diameters is the height if I times by 3. A diameter is 2 radiuses. So the height must be 6 radiuses, which I can plug in right here. So pi r squared 6r. So 6 pi r cubed would be my volume. Okay? Alright? We just took the test. Alright? We just took it. That's it. Alright? So now you're very focused on what you need to prepare, and I've given you about a bazillion papers here with all kinds of problems on it to do that. So, are we panicking about it? No. And we sure as heck aren't waiting till Monday. We could probably do it tomorrow, but we won't. We'll review again tomorrow, Dana.
So the stoichiometry stuff is on the list. Yeah, like, is that?
I cut the word problems way back,
Oh.
because the other teachers did. They're so much easier than I am. You guys got so unlucky. All right, so of all the things we just did, and there's nothing special about that sheet that I chose. I just had to pick one to get started. So what kind of a problem do we need to, oh, I know one we need to practice. Find the sheet that at the top says Precal A period 5 is amazing. Precal A period 5 is amazing. And it says practice test 1-5 to 1-7. Find it? So period 5 is amazing. Practice test 1.5 to 1.7. Problem number 1F. This is one of those where I've drawn the picture, and you have to tell me what happened. So let's look at the given picture, which is the one on top. Okay, and then look at the one I drew there for problem F. Can you see anything that has happened?
Yeah, maybe y, negative.
It looks like it's upside down.
Yeah, and the absolute value of x.
I
And left
don't
one.
think I've done an absolute value. I think
No,
I've
it's
shifted
left
it.
one.
Left one.
Aren't you there on the right side of that?
But it's still below one. Or it's below x. Below the x-axis, so it would be
Okay.
Negative f.
If you had mirrored, the two sides were looking, hey, Dana, listen to me. If you mirror, the two sides look exactly the same. Does the right side of that picture look exactly like the left side? No. There's no mirroring happening. I did turn it upside down, and I need to get one unit to the left. So how would I write that?
Y equals negative
F
of x plus 1.
x plus 1, you got it.
Yeah.
That's it. That's it. That moves you to the left and turns you upside down. Number 7. I'm just picking ones that we've already practiced. Number 7. Consider the function described by all this. Write the equation of the single rectangular equation described by these equations. That means, give me an equation in x and y. X and y are your rectangular variables. We're on number 7. So what do? If I have to come up with one equation in x and y,
Then you will square it on both sides.
I could square this, that would be handy. And then plug that in right here. So y equals x squared minus 3 would be my answer. When you have to write an equation in x and y, and that's the way it's worded on the test, that means get rid of the t's. Do something to get rid of the t's. So we substituted them out. 8, 1 to 1?
No, no.
No. Explain your answer. Does not pass
The horizontal.
horizontal line test, not 1 to 1. Number 4, prove these are inverses. This looks a lot like the one we already did. We're gonna prove their inverses regardless of what other ideas you have. If you wanna get credit for this problem, you are going to show f of g of x and g of f. Okay, this is problem number 4. We've done all these problems already, just redoing what you've already done. The kinds you've already done. So, what does this mean? The order here doesn't matter, we can do whichever one.
Put G tab.
This says take G and plug it in. So 2x minus 1 over 2 plus 1. That one worked, right?
Yep.
This is what we want to have happen. Right? And then F, so this whole thing into here. So 2x plus 1 minus 1 over 2. Those go away. And that one works also. Now, let me show you, because I don't know if you're going to get a test where it actually works or not. Let me make this number right here a 3 to show you what it looks like when it doesn't work. So this one, if I change that one number, this one would say, take that and plug it in here. So 2x minus 1 over 2 plus 3. So x minus 1 plus 3, see what happens? I don't get x, I get x plus 2. So that would be a no. And you can stop right there. There's no point in doing the other one because they both have to equal x.
So like say you were on like the test or something, there's a question about that, and it's like prove that they're inverses and explain why, would we just say, yes, they're inverses because they both equal x?
It's because this equals x and this equals
So,
x.
okay, so like because g of x equals
Yep,
x.
yep, 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 yep. Or f of g of x does not
It is
equal
not
x.
because it equals x, because f of x equals x plus
That would be your
Okay.
rock. On that page,
Yeah.
number 10, what is your equation gonna be? Yeah. Okay, that's the problem. You need to go back, watch the videos and do the review, okay? Okay? Jake, what's the equation gonna be?
Y or b equals 16 minus 2x, or times 14 minus 2x, like that.
Yep, there's your equation. What's
Wait,
your
do
domain?
they have to be here?
0 to 7?
Yeah.
And then we're gonna type it in second calc max and get our maximum. Okay? All right, so here's what I need for you to do for tomorrow, okay? For tomorrow, I need you to kind of look. The first thing I did today, I went through and I did every problem on the test, okay? Now I just started doing some extra examples. I need you to look through this packet and draw circles around or stars by the ones that are on the test. That's that first set of problems I did with you that you need extra practice with, and you can get extra practice out of it. No, you can stay after school.
What?
You can stay after school. Okay. All right. Now, everybody knows what you're doing for tomorrow, right? Okay. And your grade 7 homework, I might wanna get it done before then, so I can check and return it to you. I will do that.